So g'day, welcome back to, well I was going to say Good Meadows Coins and Banknotes, but this is a channel, hopefully this gimbal's actually okay. So what we are talking about is today weathering. So there are two concepts in geology that you would actually know. Sorry, the sun's in my eyes. It's quite a nice day. It feels like it's 20 degrees. But I've still got my jacket on. Okay, so weathering and erosion. So the difference is weathering is basically this. So what we have here is the material being broken down. Okay, material's been broken down, so this is the Bacchus Marsh Formation, and it's turning into this sandy type material. So this is part of weathering. So as you can see, you have a large outcrop of conglomerate or tillite. It has a lot of nodules, and the surface of it is covered, looks like with lichen, and when you touch it, it's actually coming off like a silty type of texture. So this is part of weathering, in which I would say it's probably silt or clay is the actual matrix. And then we have clasts of larger rocks. So this one's probably about 10 centimeters, and these come from somewhere in Antarctica, so somewhere down south. So the breaking down of these bonds, that is clay, from a compacted rock into an actual clay. So this type of material here, so this is the soil. So this would have at one time been part of this formation, but now it's been mixed with organics. And so that is a weathering process. That's part of erosion. So erosion is I would say a subset of weathering. So you've got the breaking down of the material, which we have here. So as you can see, this material looks like the larger rocks stick out because they're a lot harder, take a lot longer time to actually weather, and the actual matrix, which in this case I also think is clay, could be calcium carbonate, could be anything, but as this is glacial material, it's probably all different types, from sand size to clay size, which makes up the matrix. What was I talking about? Yeah, so that matrix is eroded first because it's a lot softer, and the rocks are a lot harder, so they stay in formation a lot longer. Eventually they'll be eroded, but can you see any fossils? They might be fossils. No, I don't think so. Just looks like a striated rock. So that is part of the weathering process. And if you can see, this is not rock anymore, it's more like a soil. So this is in situ, and the actual material has been fairly weathered, but the rock itself, so the clasts, the pebbles, are still noticeable, still rounded. Then you got quartz. This come from a later time period. So this is basically weathering. Okay, then we have erosion. That's taking this material and transporting it away from the actual site where it first was. So we have those boulders. So just for this video, those boulders, they're not come from that material there. They come from somewhere on the side here. So that transport of those boulders from here to there is erosion. So I hope this makes sense. Weathering is the breakdown of material in situ in the same place, so it's not being moved. And erosion is taking that material from one place and moving it to another. So in this case, it is mostly water. It's also can be the wind as well, and also plants. Plants are more likely to do the weathering. The erosion will be the wind and the water. So in dry times, this would actually become dry, and that sandy material will be blowing around. But also in heavy downpours, that sand material will be washed into the actual lake, and for a time it will be deposited in the lake, but when there's a flash flood, that material will be washed downstream, so a lot more energy will actually take it away, and eventually that material will be end up in the ocean. Or like this is an artificial lake, so I don't think in a long period of time the concrete's going to hold up, so eventually this will be washed away. But if it's a real lake, like Lake Corangamite in central Victoria, which is naturally dammed by basalt, eventually the lake could be filled in, and that itself could make its own geological formation with its own unique fossils that around at that time period. So basically we have the river coming from the south. Okay, that's the north, so it's coming from the east, should I say. So that's the mouth. Actually no, that's not the mouth, that's the actual source of the river. And there's also another source over there, so that's why we have valleys. So those valleys have been cut by the actual river, and because these valleys are about 200 meters above sea level, nature wants this whole landscape to be at sea level, so to be the lowest point possible, and as long as this is above sea level, it's going to be eroded. So those animals over there, they don't help in the stability of the actual area. They would, because there's no trees, this is more susceptible to mass wasting, which means that that hillside could actually collapse depending on the geology of the area. So if the strike and dip's actually like this, which we see in the Rocky, it's not, it's more like that. But that's Pentland Hills Volcanics over there. There should be somewhere over there that is the actual unconformity. So that will be massive, but it would also be faulted and should have a lot of fractures in the actual material. It's olivine basalt. Okay, and then I can see it over there. That's pretty much the Bacchus Marsh Formation. And underneath this is the Castlemaine group, so it's Ordovician. This Bacchus Marsh Formation is Permian, so about 250 to 280 million years ago. The Silurian Ordovician stuff is what, 480 to 420. I think 450 roughly is what they dated as. And the Pentland Hills is about 60 to 55 million years ago. So you've got 3 different types of geology. And then you've got this material, which we are on. So there's actually a thin veneer of, actually I think it's been eroded here. It's more over that way, which is another formation. It hasn't been consolidated. And that's just the river gravels. So that's basically weathering, which once again just breaks up the material, breaks up the rock, and erosion, which takes the rock that has become a soil and takes it to a lower point in the landscape. It's a beautiful day.